Okay, so in this video I'm going to explain about bootstrapping using my R script. You may edit it, but I just want to, explain the workflow and the rationale and the key principles. Basically, what you're looking for is kind of generate artificial samples giving your original sample, ideally using the same number of data points in your generated samples, and then you look and you draw a lot of artificial samples from the original sample, so like very large number. There is no like a specific number which is considered large, but very often it's something like 6-digit, like 100,000 or something like that. That's what you see in papers very often. I think it's just a round number and it's large enough. And I will explain. And then when you draw on these samples, right? So you would like to do tests for, like, for example, Rayleigh uniform test for uniformity, for like uniform distribution on the circle. And every time you run the test, of course, you get your stats, such as the direction, the mean direction, and the vector length, and the p-value, and so forth. So in this case, one strategy is to look at the vector lengths only for each test, and you do a lot of them, and then look into the distribution of these vector lengths. Okay, and if you then look into this distribution, you would like to see the tails, where on the left hand side, on the right hand side of this distribution, you have quantiles for, like, for example, 2.5% on the left and 97.5% on the right, so that together this comprises 5% of your sample. And then you basically looking into these percentiles in terms of the vector lengths, and then you're saying, okay, in the worst case scenario, and you compare your vector length with this left percentile, basically, or quantile. So I give you example in this code. You need to start by importing library which is called circular. I had it installed. If you don't have it installed, then you need to install it. So you go here and you do circular. That's this one. Click install and install it. Because I already installed it, it was imported now. Now you need to prepare your data. For the training purposes, I contrived some data. Your format can be different, but basically it's an Excel spreadsheet. So originally it was like this. This is just one example. There is no header. All these values are in degrees, not in radians, and all of them like individual mean directions of individual animals. Okay, and then you can save it as a CSV, so you can browse to your folder and save it as a comma delimited file. Yeah, I already done this, and I now have this sample, which I call small sample. It's contrived data, so I was making kind of directed group mean in the first quarter, like maybe 2 o'clock or something. So you can see that the clustering roughly around first quarter between 0 and 90 degrees, and it's relatively small data sample, only 11 points. And then I made what I call large sample, relatively large, where I doubled this. Now it's 22 instead of 11, and I increased the concentration probably a little bit. It's still concentrated in the first quarter. So they both in my folder. So you have this, for example, it's just for illustration purposes. And I show you, the outcomes for both scenarios when we use smaller or larger data sets. So first you need to set your directory. I commented this out, but basically just because you need to insert your disk and the path. You can do it, of course, using this point and click. Tool. So that's here. Then you can set it as a working directory. It's the same as running this, but make sure you edited this. So once you're here, so those are my data sets, these two CSV files. Let's start with the small sample. So I first read this data. So now I have an object which is data frame with 11 data sets. Okay. Forget about this line 11 for now. We'll come to this in a bit. Now I want to know the sample size. It's just this line making sample size. It's just giving you 11. Now I convert all of these numeric values to be angles. Okay, and that's why I need circular. I need this function circular. And yeah, my rotation is clock. So clock meaning that, so by default, like east will be the 0, but if it's a clock, I think your upwards looking 12 o'clock will be 0. Okay, so now we're coming to like routines for bootstrapping. Basically, you would need a list for the results of bootstrapping, and we initialize or create it out of the blue. For now it's empty. We just prepare it. We will be populating it as we're going through the for loop, which is here, which is this one. So I think we would need empty matrix, because when we populating boot, we will be running a raw circular test, and so we need matrix here at some point. I forgot why, but so we create empty matrix called R. So in R it will be vector length for each test. So number of calculations, it's how many times we bootstrap, how many times we do these calculations. Like I said, it's some round big number. Now in this for loop, what's happening in this for loop? Basically, we are going 100,000 times, and we do calculations of the raw circle test here. But we prepare samples for this test here, one line before. And how we do that, we are using a sample function, which is built-in function. We explicitly put, even if I don't put this size, sample size, blah, 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 it will be taking the size of the original sample, but I do it explicitly. So you can see that the size of each sample, which is drawn randomly, will be the size of original sample. We do it with replacement, which means that each value can be drawn more than once. So for example, we want a sample of 11, but we can have double 34, and we may have nothing, like no 78, for example, but double 34, something like this. So we draw this with replacement, and we calculate a raw circular, and we are actually drawing R, so the vector length, out of the results, because results are the least, I think. Anyway, so we're drawing R, and we put R into like So we, yeah, and we into the list, I think, under the index. So yeah, it's in the list under the index, and will be growing list. Oh no, in the matrix, in the growing matrix, under the index from 1 to 1000 hungry. So we do that. Number of calculations. So now I run this for loop. It will take a while, especially if your sample size is big enough and computer is slow and your number of bootstrapping is large. In my case, on the laptop, it will take maybe a minute and maybe 2 minutes for like 20 something samples in each test. So we ran it, so there was this sign here, maybe you noticed, and now it ran through. So we can summarize this R, which is a matrix. You can so this is the median, so you can skip this is optional, but you want quantiles. You want here quantiles. Where you put them depends how conservative you are, what reviewers expect. So very often it's like, I want to have quantiles which are together making 5% of the sample, and my quantile points will be 0.025 and 0.975. So together they make 5%. So 2.5% on each side. So we run this, and now we have this point. So remember, that's kind of worst case scenario, especially you're interested in the 2.5 point. So worst case scenario, if you're very unlucky. So imagine your sample was actually content oriented, but it's just relatively small, and some birds were not the best, and in 2.5%, so it's a very small percentage, they will be messing up your mean group direction. So what is this worst case scenario? Basically, then you can see that it's a vector length which is 0.38 or even less, and if you then compare with your this is from Bachelet 1981, you want to see the critical levels for the sample size. So we're dealing with something between 10 and 12, so we're kind of here. And for different critical levels, so for like this proverbial 5% level, it will be interpolated between 0.54 and 0.49, so let's say something 0.51. So if you are still above this, in a worst case scenario, you can say that after bootstrapping we found that our sample, bootstrapping showed that basically worst case scenario will still have directedness, but not in this case, because here it's lower. So worst case scenario will be technically not significant. That's why I have a second sample, a larger sample. So let's boost your sample size, okay, from 11 to 22. Let's delete this one, and let's repeat for the new sample size, which is 22. Then we do the rest the same. So we do this. So now it's going to take a little bit longer. You can see this sign. Don't interrupt, just wait until this has disappeared. When it's disappeared, it means it has been run through. Okay, so it ran through. You can skip the summary, you can do the quantiles, and you can see now that your worst case scenario for these quantiles will be 0.59. Now if you go back, now you're dealing with much larger sample size, which is 22. So you're dealing on the 5% level of 0.36. In your case, even in the worst case, well, in quite bad scenario, your sample will be at 0.59 concentration. Okay, so which means, yeah, your bootstrapping showed that you know, that most probably your sample is oriented. In this case, it was primarily, well, because I probably contrived this second data set to be a bit more concentrated than the first one, and because of the sample size doubled. I think both of these things. So if anything is not clear, I'm happy to explain further. Sometimes people use it for other way around, so just to prove that whatever is random is kind of very random. So then you can use the same code, but you can compare your R length with these quantiles, but now you're looking into like whether or not you have, in the most concentrated case, whether or not you are oriented or not. If you're still not oriented, then you can say that my sample was really random, and my bootstrapping showed that randomness is in this sample, the probability of this sample being random was confirmed by this bootstrapping analysis. So hopefully it makes sense.